Uh, Thank you so much for that wonderful introduction, Cora. I it's a weird brag, right, about how nice I am, but I feel like I want to create a welcoming space for people who are beginners and maybe don't know things to feel safe asking questions. And so that's why I like to dig into to being kind. But of course, every presenter today is kind. Cora also. So, thank you so much for joining my talk today. This talk is called What a Rush! Let's Deploy Straight to Production. And I'm going to be honest with you, I'm feeling some big adrenaline now because part of what I'm doing today as part of this presentation is we're going to build our own platform from scratch using some CNCF projects. This talk was first delivered as part of a KubeCon keynote I delivered it with Mauricio Salatino. It was just a 15-minute talk back then, and now I've supercharged it into something a little deeper, yeah. So I just want to give a shout out to Mauricio, who wrote the first draft of this talk with me, and sometimes you'll see his handle around Salaboy when we dig into some of the demo stuff. So Mauricio. So I'm a technical advocate at VMware, and I'm also a CNCF ambassador. So I really love these CNCF projects. So let's do the thing. All right. Uh, there we are. Okay. So now imagine you're the developer in this diagram, and your company provides a very critical service. So important. So what your company does is it serves static images of rainbows. Your company is currently the industry leader and it wants to stay on top. And so your company does a ton of research, commissions Gardner reports, puts together a think tank of all the industry leaders, and y'all have figured out the next big trend in the rainbows industry. And that trend is spiders? What? That's shocking. I think spiders are actually the opposite of a rainbow. Wow. Okay, anyway, you're the developer, and now you need to add a spider and push that change live in front of the end users. This is scary. This is scary because your company's business might be disrupted, or worse, bum, 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 downtime. These are high stakes. Now I hear you. I hear you. I hear your thoughts. You didn't know I could do that. But like, of course, personally causing downtime is horrifying. As a developer, you should never be in that situation. That's on the company. That's not on you. And just in general, this is all a drastic oversimplification. Like, for one, this diagram drastically oversimplifies what actually happens when a developer pushes code. This is a little more accurate, wouldn't you say? And as you can see, the developer is now far, far away from production. Wait, where is the developer? Oh, the developer and application team are there on the top left corner, and the production and the production environments represented there on the left, on the right, excuse me. So now, I don't at all expect for you to understand this diagram, not all of it. It is a lot. It's complicated, and it has to be complicated when we're building complex systems across millions of users. There is no getting around this complexity. So then the big question I want to ask and answer today is, how much of this whole landscape does the developer need to know in order to do their job well? How much does the application team need to know? So, to begin to answer this question, let's talk about Kubernetes. Kubernetes and the Kubernetes APIs have many benefits. But the one big benefit we're going to dig into right now is that Kubernetes offers a clear separation of concerns between infrastructure and development teams. So the infrastructure team can take care of VMs and hardware if they're working on premises, or they can choose which cloud provider offers the best services for their particular use case, because all the cloud providers now, all the major cloud providers now support the Kubernetes APIs. And now with Kubernetes, the deployment teams can deploy their workloads in the same way, no matter where that workload is actually running. But again, I'm oversimplifying. In real life, things are more complicated. Kubernetes provides the building blocks to run these complex workloads, but I'm not going to lie, Kubernetes is really complex. Learning how to use Kubernetes can take a while. And not every developer wants to learn how to use Kubernetes. Training teams to use the Kubernetes APIs, it can be a big challenge. Another challenge is for organizations to stay current on the CNCF. I've been throwing this acronym around. CNCF stands for Cloud Native Computing Foundation. So, in this billboard style diagram, all these little squares represent different CNCF projects, the majority of which run on top of Kubernetes. So, do you want your application team to be responsible for choosing, like researching all these tools and choosing which ones they need to use for their particular use case? That's they have the what they should be doing is thinking about their application code. They should be working hard on adding that bleeding edge spider to their Rainbows as a Service offering. So enter the heroes of our story, the platform team. Larger and more mature organizations are creating platform teams to build and maintain platforms on top of Kubernetes. So, platforms are built to solve company specific needs and leverage those Kubernetes APIs, or as Nick talked about before, it's not always on top of Kubernetes, but my presentation today is. And basically, the platform is meant to encode best practices and platform-wide decisions behind a friendly platform API, and it helps it helps application teams consume complex services and infrastructure in a simplified way, following a self-service approach. So, how do you get started building a platform? The platform team, the first thing that happens, the platform team collaborates with the application teams to figure out what their needs are and what tools they're currently using. What's working well? What's a big pain point for them? That collaboration and discovery, as Kote I talked about during the first talk of the day, that collaboration and that discovery is really important. So the platform team, after that discovery phase, builds the tools and functionality that the application team needs into the platform, and it adds things like governance and security built into. Then the application teams can access what they need from that friendly API or whatever interfaces that the platform team designs for the application team. So it could be a CLI, could be a web portal. In our case here, we have a friendly platform API. But basically, the idea is the platform team manages the complexity of complex infrastructure and services so that the application team doesn't have to worry about it. So, for an example, a developer can use a platform API to create a development environment. So, in the past, if a platform team, or excuse me, an application team needed a cluster for a development environment, they might have to fill out a ticket. They might have to wait days to get that back. They'd have to install it with all their own tools. That would take time to integrate. In this case, here we have the developer asking for a new development environment, and they're saying for their use case, they want a Spiders database and a speedy Spider cache. And lo and behold, without any human intervention, the platform delivers the developer's request. So the platform team made the self-service friendly platform API that developers can use on demand to provision their own development environments as needed. The platform team additionally encodes company security, compliance, governance policies all into the platform. So the developer doesn't even have to think about it. So I'm going to do some demos here today. That's the part that gives me the rush personally. But before I get into the demo exactly, I'm going to show you through some diagrams what I have set up already so far. So when I show you a terminal, you understand what's running behind that terminal. So I've already provisioned this morning a 3-node Kubernetes cluster that's running on Google Cloud Platform. And I've installed a CNCF project, a tool called Crossplane into the cluster. So what Crossplane does is it takes any API on the planet and brings it into Kubernetes so you can interact with that API via Kubernetes. So this has two big benefits. One is that one big benefit of Kubernetes generally is that you can define the desired state, and then it has a control loop as part of how it works. So it will continuously work to make sure the actual state of what you've defined. Traditionally, this has been containerized applications. It will make sure that actual state is always in sync with how you've defined it. So in this case, we can use crossplane resources to define a desired state, and then crossplane will work to keep whatever it is with any API in sync with the actual state in sync with what you've defined. So it's common to use this for cloud services that are not running in Kubernetes, but you can use it for anything. So here behind the scenes, I've installed the Helm Crossplane provider. So this allows Crossplane to install Helm charts into our platform on our behalf. And so it's also going to, again, make sure those Helm charts are in sync with the desired state as we define it using Crossplane resources. Another big benefit of Crossplane is that you can define what you want complex stuff to look like. I'm just saying stuff, but it could be applications, it could be services, it could be extra like resources running outside of Kubernetes. You explain what you want complex stuff to look like using Kubernetes resources, but then you can offer your developers and your application teams a simplified interface to be able to provision that. So the idea is that experts are the ones who are deciding what something looks like all the deep details. But then the people who need those things, let's say a database, like the experts have to deal with the database server and all the different choices. Database experts deal with that. And then they can offer a simplified interface for an application developer to just say, I don't know, I want a small, medium, or large database, something very simple and low cognitive load for them. Okay, so here in our development environment, I've used Crossplane plus the Crossplane Helm provider to make a friendly API that a developer can use to create a development environment. So this environment is an actual Kubernetes resource that is created by me using Crossplane. So we'll see. So basically, I've extended the Kubernetes APIs to understand a whole new resource called environment. But let's see it. Let's just show you instead of tell you. So here we are. We have all that magic stuff going on in the background that I just told you about. And so what I'm going to show you first is the complex resource that a platform engineer will have made. So this is a crossplane resource called a composition. And so in this composition, I'm saying I want a V cluster, which is a virtual Kubernetes cluster that I'll talk about more in a bit. And I'm saying I'm using Helm to revision that. I'm also talking about I want to be able to use Knative from within that virtual cluster. And I'll talk more about all of this. But the point of this log thing is to show you that there's a lot of complexity on the back end that the developer and the application team doesn't have to see. So with that, now I'm going to show you the interface that the developer and application team does see for the exact same resource. So here we are with this environment resource that is a custom resource created by me. So with this resource, a developer can create a new resource called an environment. And I've defined what will happen in with that other long resource called a composition. I've defined what will happen in the platform cluster when the simple environment resource gets created. So now the developer's interface, like they can match a label if they need to. They can talk about Speedy Spider database or the Spider cache. And what's cool to point out here is like these choices are very organization specific. This isn't a generic tool that's trying to fit every use case. This is something made by the organization for the organization. It's custom. And so now we've created this environment and we're going to apply it. I want to note here that we're applying it using kubectl. So we don't have a special tool for this. It is a regular Kubernetes resource, just like Kubernetes resources that you're familiar with. And again, I'm going to use the kubectl commands to get environments. So this is like kubectl will get pods, but now it recognizes this new kind of resource called environment that I created. And we can see it's been created. So it's not ready, but coming up, it's going to create that virtual Kubernetes cluster that we'll talk about in a bit, and we're going to deploy workload into it. But that's just to get started. So let's move on, and then we'll jump back to this demo environment later. So the example platform has all of the tools and logic to create this development environment. So specifically, our example platform uses Crossplane and Helm together to create a new isolated virtual Kubernetes cluster using vCluster. The virtual cluster will, when it comes up, it will have Knative installed and already configured for the application team to use. So not only does the team not have to request a Kubernetes cluster, but it already has the tools they need installed into it already. If you don't know these projects, or I'm firing a lot of information at you about CNCF projects, if you don't want to think about it at the project level and you just get the overall points, like, hey, the cluster, the platform can do this for you. The platform can do these things using a lot of different tools. So don't lose the forest for the trees. So anyway, if you don't understand the tools, don't worry about it, is my point. All right. So platforms are not just about creating development environments, though. Platforms can do other things too. So a platform can, for example, promote the use of platform-wide tools, architectural patterns, and best practices. So like Cora said during her talk, for the developer, we want to make the right thing to do the easy thing to do. So for example, the platform team can create templates and quick starts for projects. This makes it easy for a developer application team to start a new project, and it makes it so they're already following company policies right from the get-go. They're using already verified libraries. They're using secured configurations. They're ready to go. They're not going to run into big problems later. The platform team can also curate and maintain tools for the application team to use. I think maybe literally every presentation today has mentioned the Cloud Native Build Pack CNCF project. But what it does is it transforms your application source code into a container image without using any Docker file. And you can, as part of doing that, it spins up an application called a builder, and your company or your platform team can encode your company-wide best practices into that builder. But if you're consuming it as a developer or an application team member, you just know it inputs your source code, outputs an image. You don't have to understand the complexity about what's happening behind that. The platform team can curate other tools too. The platform team can curate other tools too. Tools like Tecton pipelines or Helm charts that help promote those best practices. And then application teams should be able to modify those for their own use cases. All right, so before I dive into the second demo, just like last time, I want to say some more stuff about what's happening under the hood. So this is where we left off. It's our demo platform cluster. It has Crossplane installed into it, and Crossplane's configured to use Helm on our behalf. And so when I created that environment custom resource, it created a new namespace. And in that namespace, it created a virtual cluster using vCluster. It can come pre-installed with all the tools that the developer needs, and they can be already integrated with one another. But so vCluster, let's talk about vCluster now. vCluster is it's a virtual cluster, and what it does is it solves the problem, or helps to solve the problem, of multi-tenancy in Kubernetes, where if you have lots of teams sharing one cluster and each team gets their own namespace, then you have some problems with teams stepping on each other's toes, using different versions of different tools, needing root access to install certain tools into the cluster. Or if you give every team their own full-fledged Kubernetes cluster, that can be expensive for the organization and maybe result in a lot of power that the teams don't exactly need. So a virtual cluster is a way to carve up a host Kubernetes cluster into lots of smaller clusters that you could use it for anything. But in this case, we're using those smaller cluster for development environments. And so the same way a virtual machine carves up a physical machine into many smaller machines, this is the same thing that's happening. A host Kubernetes cluster can be carved up into lots of smaller virtual Kubernetes clusters using the CNCF technology called vCluster. So that's what happens there. And then back when I set up the cluster this morning, when I set up this cluster, there's more I put in there that I haven't told you about yet. So I also installed Knative serving into the cluster. So Knative serving it helps simplify the way your application runs on Kubernetes, and it provides some enhancements to like serverless, for example, or I prefer to say scale to zero. But that's not the point today at all. The reason I installed it for this demo was because I wanted to be able to use the Knative functions project, which is a simplified way to deploy functions into a cluster. So I'll talk about that a little bit later. But the point is, I configured with that longer crossplane resource, I configured this. Anytime an environment gets spun up from the environment, capital E resource gets spun up, it's already going to come with Knative serving running in that. And in this case, it's using the Knative serving that's running in the host cluster. But the way vCluster works is if you wanted to install something else that's not in the host cluster and you want to install it just in a virtual cluster, you can do it that way too. So when I configured vCluster using Crossplane, I configured it to sync with the instance of Knative running on the host cluster. But our developer still has the experience of working with a completely isolated Kubernetes cluster with a completely isolated instance of Knative. Even though we know it's using host resources, the developer doesn't see that at all. They just see their own piece, their own isolated instance. And then, as I just said, developers can install new tools and software into the virtual cluster too. It's just like a full-fledged Kubernetes cluster. It's using K3s as the control plane for those of you who know. And if you don't understand that, don't even worry about it. So regardless, this is the virtual cluster we're starting with now as we start our next demo. So here we are in demo 2. Back to our terminal. So we're going to do the kubectl get environments to make sure our environment is ready. And we have a ready true. So we know it is. And so the next thing we're going to do is I've already installed the vCluster CLI on my local machine. So I'm going to use vCluster connect command to connect to my vCluster. And now I'm connected to the vCluster. So now we're in our development environment. We could use it to do whatever we want. And what we want is to create a new function. So we're going to use this Knative functions project that I was talking about before. What we're going to do here is spiderize our Rainbow, right? We're going to add a spider to the Rainbows as a service application. So I'm going into a directory called functions, and I'm going to make a directory that doesn't exist, hence making it. I'm going to make a directory called spiderize and then go into that spiderize directory. So I've made a brand new squeaky clean spiderize directory. And the next thing I'm going to do is use the func CLI, FUNC. So that is a Knative functions project. And so I'm going to use this func create command, and it points to a repository that contains some templates. So we're using templates specifically called spiders. Again, organization specific. So let's go ahead and look at what that created for us in our once empty directory. That created for us, look at that. It allows us to bring in all the things we need to draw spiders on top of our rainbows. So once the function is created, in this case, during the spring, I'm using a Go. Sorry, y'all. So we're using Go here. And then from here, we can change the code. But that's not the point now. We don't have time for that. So we're just the code's already where we need it to be, and we're going to run the func deploy command. So here, we're still in the Knative functions project, and now we're running a func deploy. All right. So now there are those build packs again. When we run func deploy, this is again using that project called Cloud Native Build Packs to transform the source code of the function into a container image. so the developer doesn't have to worry about how that transformation happens. It also gives the platform team the ability to define how the image build process works. So by the end of this command, we're going to get a URL where we're going to click that we're going to use to see our function deployed into our environment. Do we have that URL yet? Yes, we do. So here we are. Oh, my heart is beating fast, y'all. I'm here in the browser, putting in that URL, and ba-ba-da-da, we have, so what we have is our virtual cluster is now running this application that we just built using company best practices. We built it quickly because we had templates, and then we used company best practices, and now it's running. So let me show you all of that in diagrams that I so carefully drew just for you. So here we are. There's the application in our diagram too. Our application that it just showed you in the browser, that is running in a virtual cluster inside of our host platform cluster. So to recap, I created and deployed a spiderized function into our freshly created development environment using Knative functions. So there is no Docker file here, and it's part of the application creation process. There was no YAML file either. But what does this part of it have to do with platform? The platform team enables developers to use already verified dependencies and best practices. So in my demo, the platform provides the templates for the function, provides that boilerplate code so the developer can get started easily in using best practices. And then the platform also provides cloud native build packs configured for your particular company's best practices to transform source code into container images. All right, so we saw how the platform helps the development process. We saw how the platform helps you create an environment, but how does the platform help the spiderized application get into production? Sadly, it's not by letting developers deploy straight to production, unfortunately. Instead, the platform can pave the path to production. So that what this means to pave the path to production is to provide the right tools to validate and apply changes for more sensitive environments like production. So for example, we can do that with a GitOps approach. We could use tool like Argo CD or Flux or Carvel Cap Controller, where the configurations for this environment are stored in Git. And then to just deploy our function to the production environment, the application team sends a pull request notifying that the changes are ready for a spotlight. And then the platform should validate these changes and only promote them if all the automated tests are green. So once the changes are promoted and the code in the Git report repository changes, then your GitOps tool is going to see those changes and then automatically sync what's changed to your production environment. So in this case, where we had no function, where we had no application, and we're adding a whole new application, it's going to go ahead and do the work of deploying the application into production. But that also works if you have minor changes, like if you're updating your I don't know, whatever image your deployment is pointing at, for example, it will update that into production too. So that brings us to our third demo. But first, let's talk about, of course, you know the pattern, what's happening in our demo platform cluster. So here's where we left off, except there's more that I have installed in there that I didn't tell you about. I'm real sneaky like that. So there's more stuff that's running in our platform cluster. So for starters, I have a namespace called production to simulate a production environment. And I installed yet another tool. I bet you can guess it. It is Argo CD. Argo CD is the GitOps tool that I just mentioned. So I configured Argo CD to watch my GitHub repo. My GitHub repo is called KubeCon Production. And whatever resources are in that repo, it's going to deploy those into the production namespace of this platform cluster. So I've already actually put an app.yaml file in my GitHub repo, and therefore that app.yaml file is already deployed into production. So I will show you. You don't have to take my word for it. So this is our development environment, and this is our production environment. So you can see app and the app.production here. In fact, I'm going to close out of our. So here we go. So this is our app. This is our production environment with just Rainbows as a service running. And then this is our YAML that has our application defined here that we're pointing at this application. This is the Git repo that it's looking at. And this is the Argo CD UI of where it's all, you can see that Argo CD is watching it. So that's what I've got going on over here. All right, so here we are. That brings us to demo 3. What we're going to do is to update that app.yaml file and add a container image that has the spider, but we're not going to touch our production environment directly. All we're going to do is change the Git repo and push it. We're going to change it in our terminal. We're going to push it to our Git repo, and then Argo CD will see the difference and it will automatically deploy the new thing. So let's go ahead and do it. So now we need to go to here. We're in our KubeCon production. So if you see here that we have I already modified this production app.yaml, so it's ready to go. So you can see what I'm doing is updating the container image from the app container image to the spider eyes container image. So let's go ahead and commit that. So we're going to call it spider eyes, of course. Haha. Okay, spider. All right. Oh, I did get status. That's because I'm being watched. I know how to do things. Okay. All right, we made the commits. And here we are. Okay, so now if we hop over here and refresh, we should see now that we have a spider eyes image. And if we refresh here, it's the same, but I knew it would be the same. The reason it's the same is an Argo CD, it has that control loop going, but it's not like watching every single second. It like maybe every 2 minutes, depending on how you have it configured, it's checking the Git repo and doing whatever's there. So it's not instantaneous. So what I need to do here is press sync, and I need to synchronize through the UI. And it says progressing. And now, oops, I clicked into it, but you can see this progressing here. And then once it says it's ready, then we will be able to see healthy. So now let's see in a production environment, is the spider there? Woo! We did it. Okay. Whoa, what a rush for real. Okay, so that's demo 3. That's how we updated our application. We updated production using a GitOps approach, and the platform helped us do that. Let's get back to the slides. Here we are. We started by requesting a new development environment for our Arachnid application team. And next, we created a function, and we deployed that function into the Arachnid development environment using no Docker file and no YAML file, and company best practices. And then finally, we saw how the platform and platform team paved the way to production by using tools that validate and apply changes that have passed automated tests. So what should you remember from this presentation? Platform teams make life easier for application teams. Platform teams do this by managing the complexity of all the tools and infrastructure needed to develop and run applications. So the idea is for developers to focus on what they do best, which is writing code. Platform teams collaborate with application teams to define and build self-service APIs. This discovery phase is very important. These APIs enable development teams to easily consume complex infrastructure. Platform teams then further improve the developer experience by implementing architectural patterns that help developers code using best practices and by encoding security and governance into the platform so that developers don't need to worry about it. And then finally, the platform and platform team can help application code reach production in a safe and an automated way. So, platform teams make application teams happy. Application teams can focus on writing code, and platforms ensure that the code will reach production safely. So, that's the end of my presentation. Thank you so much for sharing your valuable time and attention with me. Thanks again to my KubeCon keynote partner, Mauricio Salatino. It goes by Salaboy, who made the original presentation with me. The big QR code is a link to the GitHub repo to our presentation last year. It's a little stale, but it's mostly good. I used it as the basis for all the demos I made today. And then the little QR code is just if you want to learn more about me. But if you do want to play with all those CNCF projects I touched today, this big QR code is a great place to start. And if you have any questions, don't be shy. Thank you.